In the next section, decimals, percents, and scientific notation. So a couple of the DAT topics we're going to talk about today, starting off with decimals. We're going to talk about adding, subtracting, multiplying, and dividing decimals, then rounding. That second topic of percents, we're going to talk about percent increase and percent decrease, and then percents for you to memorize. And the last section is scientific notation, adding, subtracting, multiplying, and dividing in scientific notation. So first, a number written as a decimal or in decimal form will have two parts. Number one, it will have a whole number part, and part two, it will have a remainder or the decimal part. For example, 24.461, there you see 24 is the whole number part, and 0.461 is the remainder or decimal part. Adding and subtracting decimals. So adding and subtracting is not difficult with decimals, but there is one super important rule to remember so you don't accidentally screw it up. Lining up the decimal points. Keep in mind for this test, we're trying to not use a calculator whenever possible, so that's why we're going to be talking about this. So here's an example of what I mean. 4.53 plus 1.21, we can write like this. So you see how the decimal points are lined up? This makes sure you are adding, subtracting the right numbers together. So most of you can probably do this in your head, 4.53 plus 1.21, but if you need to write it down, that's how you write it down. Here's another example, 4.95 minus 2.3371. For this one, I want you to pause the video and try it on your own without a calculator, and let's see how you can do. All right, 3, 2, 1, let's move. So 4.95, you need to line up the decimal points, remember. This one is actually a little tricky because it introduces something I haven't talked about yet, which is what to do when one number is larger than the other one, meaning that it has more numbers after the decimal point. You can see I've lined up the decimal points, but now this 7 and 1 have nothing to subtract from. So what do? We just add zeros until they have an even number of digits right at the decimal point, like that. And we can do that because this doesn't change the value of the number, right? 4.95 is the same as 4.950, It's all the same. Then we subtract these numbers and we get our answer. So that comes out to be 2.6129. Multiplying decimals. This one's pretty quick. So multiplying into decimals, I was kind of struggling to put into words for our PowerPoint here, but this is my best effort. We'll do an example right after so you can understand what I'm talking about better. So first we multiply the numbers like you would if the decimal weren't there. Then step 2, count how many decimal places there are in the two numbers being multiplied. Step 3, place the decimal point into the answer, that number of places that you found in step 2 from the right. So like I said, let's do an example so I can actually show you what the heck I'm talking about. So first off, on the right, here's what I just read to you. Left, though, here's our example. So 4.3 times 2.5, let's write it up over here. And so our first step, multiply the numbers like you would if the decimals weren't there. So what I mean is multiply 43 times 25 using your favorite rules, however you were taught in elementary school or middle school whenever you were learning all this stuff. Now, if you need help on remembering how to do basic multiplication without a calculator, I can make a video for that on how I was taught like 20 years ago, maybe longer. I know everyone was taught different ways based on how old you are and what part of the country you grew up in. So I'll make that video if we have enough people asking for it. Otherwise, I'm going to assume you know how to multiply numbers. So the way that I did it gave me 1075. Now this was all step 1. The answer of 4.3 times 2.5 is not 1075. I hope obviously. That was just step 1. Next we have step 2, which says count how many decimal places there are in the two numbers being multiplied. So we look up here at 4.3 and 2.5. How many numbers are to the right of the decimal point? 1, 2. So we come back down here. Well, I guess that was step 2, is that we have two numbers to the right of decimal points. Then step 3, place the decimal point into the answer, that number of places that you found in step 2 from the right. So again, in step 2, we saw that there were 2. So for step 3, we place that decimal point first all the way at the end, and then we scoot it over twice. So here's our illustration for it. 1, 2. Now, the correct answer is not 1075, it is 10.75. And a super quick way to check your answer when doing these is to just make sure the answer makes sense. So in this case, about 4 times about 3 equals 12. And the answer that we got was 10.75. That's about 12. So yeah, it makes sense. If my answer was 35 or 1075, then you can see that is definitely wrong because it's not even close to 12. So either go back and try again, or flag it, make your best guess, and move on. Next, we're dividing decimals. Technically, you can divide decimals by multiplying the top and bottom number by power of 10 until you have whole numbers, and then divide those new numbers using long division, but that will take so much longer than just using a calculator. So I put little stars on this slide here. This is one of the few times I actually recommend using a calculator. It's just faster to type it in, and it probably won't appear on your test more than once. So if you have a question where it's asking you to divide decimals, just plug it in. Next topic of decimals, we're rounding decimals. This is probably the best time to quickly talk about place values because the DAT could require you to round the answer to a specific place value. So let's look at this number here, 124.461. This number 1 is in the hundreds place. The number 2 is in the tens place. Number 4 is in the ones place. This number 4 is in the tenths place. This number 6 is in the hundredths place. And the number 1 is in the thousandths place. So I'm not going to talk about that anymore, but you should know those terms, and if they ask you to round to the tenths place, you should know that's right here. If they ask you to round to the tens place, you should know that's up here. There you go. When it comes to rounding, there's really one rule, and that is when asked to round your answer to some place value, look at the number immediately to the right of that place. If the number is a 5, 6, 7, 8, or 9, then you round up. If the number is 0, 1, 2, 3, or 4, then you round down. All right, let's practice with this question. Pause the video and solve it. 3, 2, 1, let's go. What is 2.4 times 1.5? Round your answer to the tenths place. So we write it out, 2.4 times 1.5. And remember, we are first multiplying as if the decimal's not there. So we're doing 24 times 15. I changed my number to 2.5 times 1.5. So we're going to do this now. 25 times 15 comes out to be 375. Then step 2 is figure out how many decimal points we have to the right, which is 1, 2. So we scoot it on in 2 spots over to have 3.75. But wait, did you remember round your answer to the tenths place? The tenths place is where the 7 is located, right? And so we look at the number to the right of that, which is the 5, and decide whether we should be rounding up or rounding down. And the 5, we always round up. So the answer is actually 3.8. All right, percents. First of all, quick definitions here. Percent is a part divided by a whole. Possible question types. There are 2 of them. Number 1, simple math. What is 20% of 50? Possible question type number 2, word problems. If there are 35 boys and 13 girls in a room, what percent are girls? So here's a table of some common percents to know. You should have all of these memorized. Most of these you probably already have memorized, so this shouldn't be too hard, but there might be a few that you need to study up on and make sure that you know. One thing to note, for 2/3, it's actually 0.666666 forever and ever and ever. I rounded that one to 0.67. Same with 1/3, that's actually 0.33333333 forever, and I rounded that to 0.33. So those are the 2 that I've rounded here. All the others are exact numbers. So like 1/8 is really 0.125. I'm not rounding that. That is exactly 1/8. I'll have this table for you at the end in my summary slide again if you want it for a reference later. Next topic, percent increase and percent decrease. So first, percent increase is the amount increased over the original amount times 100%, and percent decrease is the amount decreased over the original amount times 100%. Let's talk about this one a little bit more so we can get a better understanding of it though. So here's an example question for you. Safarmo originally scored a 15 on the QR section of the DAT. After taking a new super helpful online course, she took the exam again and scored a 25. What is the percent increase? So if you feel like you already know how to solve this, pause the video, use the equation I have sitting up there, and solve it. Otherwise, we're gonna go through it right now. 3, 2, 1, let's go. So first off, the amount increased. I guess I really should back up here. We're looking at increase, right? So we're looking at this equation up here, percent increase, which is amount increased over original amount. So first we need to find the amount increased. And that amount increased is the new score, 25, minus the old score, 15, which is 10. And then we need to find original amount, which is original score, 15. Now we take 10, amount increased, divided by 15, the original amount. That gives us 2/3. That can be simplified to 2/3, which is a percent you should have memorized from my previous slide, 0.66666 forever, or 0.67, which is a 67% increase. And as a side note, this times 100% is really just to change the unit from a decimal 0.67 to a percent, 67%. So you could kind of forget that and still be totally fine. It's just the amount increased divided by the original amount. Same with percent decrease. Talk about scientific notation. The standard form of scientific notation is a times 10 to the power of n, where a is a coefficient. Typically a will be between 1 and 9 or -1 and -9. And I can almost guarantee the answers will be in that range of 1 to 9 or -1 to -9. And then n is the exponent. So an example of this is 7.3 times 10 to the third. First, let's talk about adding and subtracting scientific notation. Adding and subtracting numbers need to have the same exponent. If they do not, you need to convert one of the numbers to have the same exponent. Or said a different way, it is not legal to add or subtract these numbers unless they have the same exponent. So make sure that they're the same. Here's our example question. 3.0 times 10 to the fourth plus 2.1 times 10 to the third. If you think you already know this topic and how to solve this problem, pause the video and do it yourself. If you don't know how to do it yet, let's talk about it. 3, 2, 1. Okay, let's go. So right away we see that the exponents are not equal on this, the 10 to the fourth, and this one, 10 to the third. So therefore we are not allowed to add them yet. First we need to convert one of them so that they match. So I just picked the first one, and we changed 3.0 times 10 to the fourth to be 3.0 times 10 times 10 to the third. Now can you see what I did here? I pulled out one of these 10s. There's 4 of them, 10 times 10 times 10 times 10. That's how you get 10 to the fourth. I pulled out one of those 10s. And now we have the 10 here times 10 to the third. And then we just kept 2.1 times 10 to the third the same. Now, simplifying this further, we now have 30 times 10 to the third plus 2.1 times 10 to the third. Now our exponents match, we can add them. And that gives us 32.1 times 10 to the third. But wait, remember the rule from that first slide that I showed you, which is the number, the coefficient at the beginning, needs to be 1 to 9. And that is 32.1. That's not between 1 and 9. So we need to change it. And the way we change it is to do the reverse of what I just did at the beginning, right here, separating the 10. Now we just separate this 32.1 and scoot it back over onto the 10 to the third. So this is what I'm trying to say. 32.1 times 10 to the third is really 3.21 times 10 to the fourth. A quick tip here, to save you a step or two and therefore some seconds on the test, convert the number with the smaller exponent into the larger exponent, if that makes sense to you. So for example, in this problem, I could have saved myself a step or two if I would have kept 3.0 times 10 to the fourth, and I instead converted this one to be 0.21 times 10 to the fourth. If that makes sense to you, great, use it. If it doesn't make sense to you, not a big deal. It's only going to save a few seconds on the test, so nothing to stress out about. All right, multiplying scientific notation. First, you multiply the coefficients together, and then we add the exponents. So let's do an example so you can see what I'm trying to say. 4.2 times 10 to the third times 2.0 times 10 to the second. Step 1, multiply the coefficients together. Coefficients are 4.2 and 2.0, by the way. So we get 8.4, which you should be able to do 4.2 times 2 in your head for that one. And then we add the exponents. So 10 to the third, 10 to the second. So we should have 8.4 times 10 to the 3 plus 2, which is 5. Dividing scientific notation is incredibly similar to multiplying, but now after we divide the coefficients, now we just subtract the exponents. So here's what I'm talking about. 5.4 times 10 to the 8th divided by 2.0 times 10 to the third. We first divide 5.4 divided by 2, and then we're going to subtract the exponents. Then we're going to subtract the exponents, so we do 8 minus 3. And that gives us 2.7 times 10 to the 5th. Many of you can probably do 5.4 divided by 2 in your head to get 2.7. If you can't, then sure, use the calculator. But again, we're just trying to minimize use of the calculator whenever possible. So let's start practicing now to do more mental math so that we're saving time on the test. That's it. Next, let's talk about taking a number written in scientific notation and squaring it or taking it to the third power, etc. Exponents with scientific notation. Step 1. Take the coefficient to the new exponent. Multiply the exponent by the new exponent. 3. Adjust the coefficient to be between 1 to 9 or -1 to -9. So let's do an example so you know what the heck I'm trying to say. Example, 4.0 times 10 to the third squared. First, we take the coefficient to the new exponent. So let's rewrite this in a way that makes a little bit more sense by doing both step 1 and 2 here at the same time. So we square that 4.0. We take the coefficient, that's 4.0, to the new exponent, squared. Now we have 4.0 squared times 10 to the, step 2, multiply the exponent by the new exponent. Multiply this 3 by 2. Here we have it, 3 times 2. So now let's simplify that. We get 4 squared, which is 16, and 3 times 2, which is 6. 16.0 times 10 to the 6th. Then, step 3, which you don't always have to do, but it will come up relatively often, is adjust the coefficient to be between 1 to 9 or -1 to -9. And right now we're at 16, so we need to change it to 1.6 times 10 to the 6th, which gives us 1.6 times 10 to the 7th. All right, there's our summary slide, decimals, percents, and scientific notation. What we talked about today was how to add, subtract, multiply, and divide both decimals and percents. We talked about adding, subtracting, multiplying, dividing, and taking to an exponent when numbers are in scientific notation. We talked about common percents to know. I have that picture on the next slide, by the way. And then percent increase and percent decrease. So hopefully this was helpful. Here is your common percent slide. There we go. And I'll see you in the next one.